Okay, guys, if the sub hasn't given you a sheet to do this with, you need to ask for one, okay? This is going to be kind of like your fun sheet, but you're going to be doing it in class, okay? Since I'm not here with you today. All right, so let's go ahead and get started. So we're starting today, looking at groups and families of the periodic table. All right, so here's your notes. And like I said, this is your fun over families, excuse me. Okay, so the first thing we want to do is we want to recall the number of valence electrons in the following groups. Okay, this group 1 has 1 valence electron, group 2 has 2, group 13 has 3, 14 has 4, 15 has 5, 16 has 6, 17 has 7, and 18 has 8. Okay, now I haven't told you this, but you need to write this on yours. In the middle, those transition metals have 1 to 2 valence electrons. Okay, we hadn't really talked about that until now, so make sure that you write that down. Okay, so group 1, 1, group 2, 2, 3 to 12, 1 to 2, 13, 3, 14, 4, 15, 5, 16, 6, 17, 7, and 18 has 8. Okay, moving on. So, why is this important? Here's why. Because elements in the same group or family, and remember groups and families run up to down or vertical. Excuse me, guys, my throat's bothering me from this stuff I've got. Run vertically, okay? So we're still talking about groups and families, which you already know. They have similar characteristics or properties. Okay, and this is just like your own family, okay? You and your own family share very many characteristics and properties. Probably, more than likely you do. Okay, so here we go. So let's look at the names of the families on the new periodic table that I've handed you out today, okay? You need to be able to pick out these families by name, okay? And the ones I have listed here are the ones we'll be referring to the most, okay? So yes, you do need to be able to call these groups or these families by this specific name. Okay, group 1 is the alkali metals. Group 2 is the alkali earth metals. Group 3 is the transition metals, which we've referred to those before. Group 17, moving always 17, is the halogens. Okay, so locate this. I want you to locate it and look at it on your new periodic table. And group 18 is called the noble gases. Woo-woo. Okay. Now, so why is this important? Here's why it's important. Because of the rule of 8. I want you to think about the rule of 8 when we start talking about, and I want you to think about valence electrons. Okay, so to be happy, there needs to be 8 electrons in the valence shell. Okay, that's the reason why when you start watching these video clips, they'll say that some of them are not found in nature alone. And the reason why it is because they're so unstable that they have to hook up so that they are stable, okay? And so let's talk about that for just a second. Okay, so the number of valence electrons indicates an element's reactivity, how reactive or how stable it is, okay? Now, let's look here at this rough drawing that I've done of the families and groups, and I've put the number of valence electrons in each of these groups. So now let's talk about how the reactivity is. Okay, of course this is hydrogen up here. It also belongs to group 1, but elements in group 1 or family 1 are extremely reactive. Okay, 2, they're very reactive. They're not quite as reactive as group 1, but they're still very reactive. The transition metals are reactive. Those in group 13 are reactive. Those in groups 14 and 15, they vary depending upon the element. Group 16, they're very. Group 17, oh, we're back to extremely reactive. And group 18, they are not reactive. Okay? And that's because they're happy. They're happy already. They already have that rule of 8. They already have 8 valence electrons. Okay? So they don't need anybody. Hence, they're the nobles. There are noble gases. Okay, so here I've highlighted groups 1 and 7. I want you to see here, this is a way to help remember this whole chart, is the ones on the edges minus group 8, because remember, they're the nobles, group 18, with 8 valence electrons. But group 1 and group 17, besides, they're the two on the edges, minus the noble gases, right? Okay, so they're the most extreme in being reactive. Okay, now you can see, whoops, too fast there, but the blues 2 and 6, they're very reactive. Okay, then I go to the insides, the transition metals and group 13, they're highlighted in the, I guess you call that pale brown. Those are reactive, and then groups 14 and 15, they vary depending upon the element. The reason why I did the color coding here is because I want you to see that the extreme go together. As you move in, they become very active, then they vary, and then as you get towards the center, they become less reactive. So now I've put this on a arrow for you to see. Now, first we got to remember that group 18 is not reactive. Why is that? They're happy, right? Remember, they're happy. Okay, now, at the both ends, we found that they're the what? Most reactive. And the way I've slanted this arrow shows you even within those groups or families who's the most reactive. So if I look at the family in group 17, the halogens, at the very top I will find that it is fluorine. And I would like for you to find fluorine on your periodic table and see that that is one of the most reactive in its own family. Okay, so even within group 17 at the top, fluorine is very reactive. Now, look at the bottom. In group 1, you will find francium, Fr. You will find out it is the most reactive. Okay, so if I could color this whole thing, as far as reactivity goes, remember that as you get closer to the edges of the periodic table, and the reason why is because 7 would be very reactive because it's so close to having 8 that it's very important to it to get one more. The same thing goes from group 1. They only have 1. If they lost that 1, they would be at, I guess you would say in reverse, that 8. Okay, so you see 7s, the groups with 7 valence electrons and groups with 1 valence electron being the very most reactive. And that works in as you go, okay? But the closer you get to the center of the periodic table, the less reactive they are. But do not forget group 18, the noble gases, they're not reactive at all. We actually call them inert, I-N-E-R-T, and they're happy. Okay, so now we're going to watch video clips. They're actually fun video clips. The first one, you actually get to see some things blowing up about each family and respond to questions that follow. These aren't videos I've made. They're just good ones I found and hijacked from YouTube.